Hello everyone. Let's solve our next problem from Google's recent questions, which is going to be find the visible number of mountains. So let's try to understand this problem. So we are given a list of peaks of mountains and we need to find how many peaks are visible. Now what does visible mean is if a peak is not falling inside any of the mountain, that is visible. Yeah, and there is one more edge case where each peak is falling at same point. It is not visible. I will come back to it later. If you look at this image, you can see this peak is visible for us. This is visible, but this will not be visible because it is falling inside another mountain. So to understand this problem, we need to imagine one thing. Let's say if this peak is falling inside this bigger mountain, what mathematically is also possible is its base is also falling inside the same mountain. Okay, so that's first observation that is key here for us. Now if you see this mountain, the first one starting at 2, it is not falling completely inside our this bigger mountain. That's why it is not a its peak is visible to us. Now let's imagine you have another mountain which is here. Now if you look at it, its base is also falling inside our bigger mountain. That's why its peak is also falling inside our bigger mountain. If I draw another mountain here, this is again inside our bigger mountain. That's why this is not visible to us. Even if I draw one here like this is still not visible because it is falling inside one of these. Another key observation that you can see here is if I start at the same point as any another mountain, it will always fall uh, inside our another mountain. So if it starts here and uh, if it ends somewhere here, but if they are starting at the same position and the another is ending before the second one, it is definitely falling. So there is no possibility that if you start before some bigger mountain and you go, it its peak will always be visible. So you understand what I mean. If and only if you start at the same point, or if you start in after the mountain like here, it is falling inside the same mountain, so it's not visible. But if you are starting before another mountain, then that peak is always visible. With this in mind, let's try to figure out how to solve this problem. Okay, so basically this comes down to finding the base of each mountain and then checking if anything is overlapping with it. We know that this mountain is going to be isolated triangle and the slope is going to be 1 and -1. So based on that information, mathematically it's going to be the start of the base will be x minus y, which is 0, and x plus y, which is 4. So this is how it's going to end here. So another mountain is 4 and 5. So it's x is gonna fall at 1, 5 minus 4, and end is gonna fall 5 plus 4, that is 9. So if you understand it, it's gonna be the coordinates for our interval problem will become x minus y and x plus y. So for this particular problem, let's draw the number line here. So this is gonna be our number line, and this is start from 0 to 9. And so first our triangle is falling on 0 and let's say 4. So this is 4. Our next triangle is falling on 1 and 9. So that's gonna be 1 here and it's gonna be all the way till 9. And last it will fall between 3 and 9. So between here and here. Looking at this, you can see this line is completely inside our the bigger line, so we can only see these 2 points, no other points. So this initially becomes a intervals problem. Okay, I want to explain one more edge case that is very important for us to solve this problem, and that is let's say if two mountains are starting at the same position and one is ending like afterwards. So in a in a peaks we could have been given the smaller one first and then the bigger one, but we want to sort it in a way that the bigger one comes first, so that any other triangle that starts at same position will always fall inside it. So if anything is starting here and ending inside, we can ignore those triangles because they will not ever be visible, because once we have visited this one and we have counted it, um, the others that start at this position and end at before this ending are not visible, so we can completely ignore that. So that is very important for us to sort it in a way. This problem, after understanding that it's interval problem, it could have been very easy to do, but they added this another constraint, which is like if a triangle is falling on the same, or the peak is at the same point. So for example, here the peaks are 1 3 1 3, so their bases will be same. If that is the case, there is complete overlap. That means none of the mountain is visible. Now the problem is, because this is a case where if let's say even if 1 3 again, if there are three mountains on this same plane, none of them is visible. I think this is really stupid, because we'll at least see one peak, but they want us to consider that you can't see anything. It crosses out everything if they are on the same plane, and this is the most critical part of this problem that makes it very difficult to code. Coming back to the code, how I'm going to solve this is, first I will create the intervals, second I will sort them based on start and max length, and third one is will ignore the same intervals. Let's take an example where two triangles or intervals are falling at the same positions. So what we will do is, we will count this as 1 when we first encounter it, but when we encounter it again the same points, we have to subtract that count, and if there are any more, we need to ignore them before subtracting, because if you found another one, then you will again decrement count, and that will be incorrect. So that's not how this will work. I know this is getting too complicated. This is a really hard problem, even though it says medium, but the code is going to be very simple. Let me go to the code and show you how it's done. Yeah, so first creating intervals. So how we'll do that is, for each x comma y in peaks, we will have 2 points, x minus y and x plus y. So this is our start and end of our interval. Now second one is sorting. So sort based on start and then max end. Okay, so to do this quickly, I will do in place sorting interval dot sort, and then key will be lambda of point p, and how we will sort is p of 0, so based on p of 0, and because it's going to be from small to high, we want to make it negative. So if the line is, let's say, 6 and another is 5, then -6 will come first. So in theory, our maximum length triangle will come first if both are starting at the same point. Okay, so this is very important for us, this case. So once we have this, now let's start the loop. So we need I for that, and let's have a total count is equal to 0. So this is us, and let's also make n as total number of peaks, so length of peak. Okay, so while I is less than n, what we want to do is, we want to take start and end from the interval of I. Let me call this intervals just to be consistent. So intervals of I. So we get start and end, but to compare this with something previously, I will add two more variables, previous start and previous end. and this will be float um, infinity minus infinity and um, float. So what we are doing, this is because we will start at some arbitrary point, and for first point it will not match with this one, so we'll count it. Okay, um, it will be more clear when I do this. So first thing, as I said, uh, let's see in this example. Okay, so our end, so previous end is minus infinity, so and next end is 4. So if our current end, which is this one, is greater than previous end, then we can count this mountain that it is visible. Okay, so let's say previous end is less than our current end. So infinity is minus infinity is less than this one, so we know this is visible. Now once it is visible, what we want to do is we want to increase our count. So count is equal to +1, and our previous start and end will change now. So it will become the start and end of this mountain. So previous, let me copy it. So previous end and is equal to current start and current end. Okay, that's it. Now we have nailed our main point, that only if the end is greater than previous end, then only it is visible, otherwise it is not. Perfect. Now at the end of this case, we want to increment our I and go to the next loop. Now let's handle our edge case, which is what if the previous previous and previous interval and current interval are same. Then, as I said, showed in the diagram before, we will consider the first one that is coming. So it will always become like, okay, this is consider increment count. So if we found a interval that is same, we need to decrement the count. And remember, there could be multiple same intervals, and because they are sorted, they will be in the same similar area. So we want to ignore all of them at once and only decrement our count by 1. So let's do that. So if previous end is equal to end, and previous start is equal to start, that means it is similar. So what we will do is, while I is less than n again, and this interval previous end comma previous start is equal to interval of I. If this is the case, then we will keep incrementing our I. So we'll loop until it is not similar. Okay, and once we have ignored all the other ones, we know that we have counted the first one, so we need to remove that count. So if count is greater than 0, and this case is important because let's say there are two, for example this one. So in this one we consider the first one, so the count is 1 and we want to remove it. That's why, but in some cases the count might be already 0, so you need to consider that. So that's why if count is greater than 0, so if count is greater than 0, count minus equal to 1. So that's it, and in this case we will continue from here, and this will be elif. So we'll not, so once we do this, we have incremented the I itself in this case, so we don't want to increment again, so that's why we are going to continue, and this case will handle all other cases for us because we have sorted in this way. So I think that's it, and let's return the count from here. I think this should work, but let me try. Yeah, I had a bug here which I'm really sorry about it if that tripped you. So the second position will be p of -1, Sorry, I had another bug which took me some time to figure out. So this interval will be start first and then end. So that was tripping me my solution off. But this should work now. Let me submit. So accepted and let me submit. Yeah, so this is working fine, and it's also a good solution. If you found this video helpful, please like and subscribe, and see you in the next one.